Hi everyone, we're now on lesson 8 of Science 10 Chemistry. This is naming compounds. Specifically what we're looking today is we have the basis for ionic compounds and how to write them correctly or predict the final compound based on the charges. And we're going to use that, but we're going to move forward with some special cases. And I would ask that you do have your periodic table in front of you, or well, basically for the rest of this unit. But what we're doing here is we're not learning any new procedures. We're just looking at some special cases that you need to be made aware of. You know, everything comes back to this. If I had to have, let's say, sodium, it's going to come together with, let's say, oxygen. And just so you know, in the future when we do our chemical reactions, there are some things we'll have to improve here. But right now, we're looking at how to balance the charges. You see, if you look at your periodic table, sodium has a charge of 1 plus, oxygen has a charge of 2 minus. You know that when these two come together, we have to have a balanced compound. So essentially, if you look at this, we have two negatives and we have two negatives via the oxygen, and we have one positive from the sodium. So how do we balance this out? What do we have to have? Well, I would write we have the Na and the O. And what we're going to have here is we're going to have two NAs. Remember, because if I have two of these, that's like saying 1 positive times 2, and that gives you a charge of positive 2. And, well, if you look right here, I put no number right there, so that means it's a 1, even though we don't see it. That's like saying 2 negative times 1, which is negative 2, and everything is balanced. I could do this again. I'll just do one more here because I think in the last video you probably, via the 288 rule and such, you should have this down by now, and after all the practice I gave you. Let's see here, I'll try another one. If we had Al, which is 3 plus, and I add that to a chlorine, which is 1 minus, and we're going to make a compound out of those, so I put the Al and the Cl next to each other. Well, which one do I have to multiply by here to balance out this compound? Well, we're going to have 3 of the Cl's, because you see, if I have 1 minus times 3, that's a charge of negative 3. And right there I put no number, so that means we have a 1. So we have a 3 positive times 1, which is positive 3. So this is now balanced out. And again, I have to move forward. I mean, I'm not sitting there in front of you, so I have to move forward, assuming that you have the ability now to find the charges or use the 288 rule to get the proper writing of an ionic compound. But like I said today, we're using everything we learned in the last lesson. We're just looking at some special cases now. First thing I want, basically what we want to look at here is called multivalent elements. And if you look at your periodic table, you will see some of these. It's where you have an element that has multiple charges. And quite often, which one do you use? Now, before I get sidetracked, I do want to say something. Maybe make a note to yourself somewhere, maybe on this, a note somewhere for you. I want you to know that in some questions, you will be told which of these charges to use, and we will come across that. But if you are not if you are not asked or told which charge to use, always use the first you read. And we read from left to right. So if you're looking at, let's say, copper, which has 2 charges, whichever one comes first on the left is the one that you want to use. And that's just a very important note that I found was not in these notes. But don't worry, this is not an overly difficult concept. It's just, this will make one heck of a difference when we start writing reactions and balancing formulas. So let me get back here to the notes. Some elements have more than one stable ion. For example, iron, which is Fe, has 2 stable ions. It has 2 plus and 1 minus. Elements with more than one ion charge are called multivalent elements. Ionic compounds containing multivalent elements must have Roman numerals in their names indicating which ion is forming that compound. Now this is where we get in, because you see what's going to happen. Sometimes you'll be told which one to use and sometimes you won't. Like I said to you, if you are not being told, you must use the one that you read first. And we read from left to right. So if there's, let's say you read and there's a 3 plus and a 2 plus, and that's reading from left to right, you have to use the 3 plus. So for example here's an example. It says chromium, and I'm down here at the bottom. Whoops, sorry, that didn't write. I'm on eraser. It says chromium is multivalent. So chromium 3 sulfide indicated chromium 3 plus ions form that compound. Interesting. So what they're meaning by that, so if you were to come across, okay, so if you see chromium, and they have 1, 2, 3, that's the Roman numeral 3, what does that mean is going on? Well, what that means is, you see, they've used chromium, and the symbol for chromium is Cr. And here's sulfide. Sulfide is S, and as you know, sulfide is sulfur. You see, which chromium did we use? Chromium has different charges. But because they wrote 3, that means we must use the 3 plus charge. So if I go up here, I'm just going to go up here. So we know we have Cr, the charge must be 3 plus. Sulfur, if you look on the right-hand side of your table, that never changes. That's going to be 2 minus. Now, from the last lesson, I'm hoping you can balance this out here now properly. So how many of each would you need? You would need 2 of these, and that would give you positive 6. And you would need 3 of those, and that would give you negative 6. So your compound would look like Cr2S3, like that. You see, they always have to write it down for you. I will do another example here. So let's say we have, I don't know, I'll go iron like this, iron to, I don't know, chloride. So what does that mean? And I'll do the side work up there. So we're going to have iron, and we're going to have chloride, so FeCl. The 2 in this case tells us what the charge of the iron is. In this case, we're using Fe2+. The charge of chlorine never changes. It's 1 minus. So which of those do I need 2 of? I need 2. So your charge would be FeCl2. But again, if I go one step further, that really is going to change if we were to take the other charge for iron. What if they said iron 3 chloride? Well, now your final compound changes. So here we have iron. It's still Fe and still Cl. But now if I go up here and show you the side work, which I would recommend, you're going to have Fe3+, and you'll have Cl1-. Well, now how many Cl's do you need to balance this out? You would need 3. So it's Fe1Cl3, and that's your compound. So again, the question will tell you, if you have a multivalent, typically it will tell you with a Roman numeral which one to use. But if they don't, you choose the one that you read first on the left. Remember that rule. Remember the rule of if it's not there, you choose the one on the left. I'll even write it again. Whoops. Okay, so if not told, use charge on left. Okay, that's really important if you are not told. Moving along here, you can find the Roman numerals to use in the name of multivalent ions by using this is interesting too. I like this one. This is kind of going backwards, everyone. This one is saying they're going to give you the compound first and help you understand which charge you have. So you see, if you take, and I'll take, we'll go with the example they have right here. Let's say I gave you FeBr2. And you're wondering in this case, well, which charge of iron am I looking at? Because if we go back, I believe iron was on this page. If you look right here, iron has 2 charges. It can either be 3+ or it can be 2+. So let's take a look here. I'm going to do my side work. So I'll do one of them up here, and I'll do one a little bit lower. So the 2 charges for iron were 3+ and 2+. So let's take a look. So here's Fe, here's Br. Now, if you look at your periodic table, the charge for Br is always 1 minus. Let's put 3 plus right there. And now I'm going to come down here. I'm going to show you the other possibility. So it's FeBr. Br always has a charge of -1. What's the other charge of iron? It's 2 plus. Now, this is our goal. So which charge of iron must we be using? You see, in the top category here, which one do I need 3 of? I would need 3 Br, so your compound would be FeBr3. If you look on the bottom, what would this compound give you? Well, how many Brs would I need to cancel out that 2 positive? I would need 2. So you see, by using that process, you know that in this compound, the iron charge that was used must be Fe2 plus. I'll do another example here for you. That's the one that's here on the page. And again, we're not doing any difficult math. We're just kind of, being careful. So in this case, we have copper 2 chloride. So what you look at here is, I'm going to write this down. So copper, I'll write it like this. Pretend I gave you this. Okay. And you need to figure out, what is the charge of copper being used? Well, I don't really know. What you could take a look at here is, we have Cu and we have Cl. Now, what is the charge of chlorine no matter what? Chlorine is always 1 minus. Now, let's see if we can kind of skip a step here. Now, it's interesting, if you look at this compound, how many Cl's do I have right there? I know I have to have 2. So if we jump back here to the right, I know I'm going to have 2 of these. So that's like saying 2 times 1 minus. Now, so in other words, if I summarize this right here, everyone, is going to give me a charge of -2. Well, what balances out with -2? Well, it must be 2 plus. So we know in this compound, the copper that's being used must be 2 plus. Hopefully that makes sense. You get a chance to practice with that. It's nothing really difficult. It's just kind of taking the compound that you've been given and going from there. Okay, let's move along. Now this polyatomics, this is something that I found has been very important for students to understand. I found it to be a little bit of a tricky thing because it's often forgotten and maybe not done properly. So if you look on your periodic table, towards the middle top, or maybe a little bit to the left in the top, you'll see your table of common polyatomic ions. And you see, polyatomic ions are made up of several atoms joined together. Now, we have to be very, very careful when we do this. So what I'm going to do is start off with a base example, and this one is not polyatomic. But I'm trying to show you that we have everything in place. So if I gave you this, if I put Na plus Cl, you would look on your table and you know that Na is 1 plus and Cl is 1 minus. So if you put those together, that's a perfect match. So it would be NaCl. What if I did this to you? If I did Na plus O. So it's going to be Na, and I would to balance this one out. Na is 1 plus, O is 2 minus. So which one do we need to double up here? Well, it should be the 2, because now we have a balanced compound. If I do one more to you here, if I did Mg plus, let's go Br, it will be MgBr. Let's take a look at our charges. 2 plus, 1 minus. Which one do you need 2 of? Well, in this case, you need 2 of the Brs. So what I'm telling you is, what we just did, that's all the math you need. We're not changing any rules, except, watch the difference. So now I'm going to erase this because I know on your video you can rewind. I just need this space right now. So what happens here, everybody? Let's start off easy. Let's say I take Na, and I'm going to add that to hydroxide. Now, hydroxide is found up here in this table. And what you'll see, it's written as OH, and the charge is minus or minus 1. Okay, remember, if it just puts minus, that means 1 minus minus 1. And sodium is still 1 plus. Now, doesn't one positive and one negative go together perfectly? Well, yes, it does. So all you have to do is put them together. NaOH. No big deal at all. What about, though, what if I did this to you? What if I took Mg and I add that to OH? Well, you see, Mg is 2 plus, and OH is -1 or 1 minus. I always write that the wrong way. So in your mind, what do you have to do with the OH? How many do you have to have? You have to have 2 to balance it out. But here's what everyone does. I'm going to show you the wrong way. Everyone does this. And I don't blame them for doing it. They go like this. They go MgOH2. But you got to stop yourself because these are polyatomics. You see, if you're familiar with math, maybe you've seen this before. This is a multiplication. It's kind of you're expanding through, and what's happening is you see this 2 gets multiplied to the x and to the 3. So actually what it would give you is 2x plus 6. So you see what's happening here. If I really break this down, how many mg's do I have right now? I have 1. How many O's do I have right now? I have 1. And how many H's do I have? I have 2. That's not right. I need 2 OHs. So the rule is, everyone, when you use polyatomics and you need more than just 1, here's what you have to do. I know I need 2 of these. You must put a bracket around that group and put the 2, because that means you get 2 of this group, just like this math distribution principle. I'll show you another one. Okay, this takes a little bit of getting used to, and believe me, we need this in place as we move towards writing chemical reactions. Let's take, I don't know, let's go Mg plus NO3. Now, NO3 is nitrate, and it is on your table. Magnesium is 2 plus, nitrate is 1 minus. So you should be able to tell by now which one you need 2 of, and it will be the NO3. But because you need 2 of a polyatomic, you must put brackets around that polyatomic and then put the 2. Okay? Let's do one more for good measure. Let's just see what we can do here. Let's throw a different curveball. What if I did this to you? What if I did Na and SO4? Well, let's double check our charges. Na is 1 positive. SO4 is called sulfate, and that gets a charge of 2 minus. So which one do you need 2 of? Well, it should be of the sodium. But the thing you have to ask yourself is, does sodium need a bracket around it? And the answer is no. We only put brackets around the polyatomics. So you can just go 2. Na2SO4, sodium sulfate. Very, very important. We'll move forward here. This is just some naming here. In order to correctly name compounds containing polyatomic ions, look at the formula and first name the cation followed by the anion. So this is just telling you here. So if you look at this one, you have CaOH2. Well, Ca is calcium, OH is hydroxide. Okay, you'll get to know these polyatomics. So it's calcium hydroxide. The key thing here is, everyone, is to really, really understand how to write these compounds, okay? Heck, I'll even see if I can throw a bit of a curveball at you. On the periodic table, under the polyatomics, here's an interesting one. NH4, which is 1 plus, I'll let you find that, and SO4, 2 minus. You see, by looking at the charges, one is 1 plus and one is 2 minus. So which one do you need 2 of? You need 2 of this ammonium group, the NH4. So what that would do is you'd go NH4, and because that's a polyatomic, you have to put a 2 and then SO4. Believe me, I'll give you some practice with this coming up, and you need to really, really make sure that you understand this process. Okay, you have to make sure that you know how to write compounds containing polyatomic ions perfectly. I can do a couple more here for you if you want. I'll take the first example. We have Mn, which has a charge of 2 plus, and CO3 2 minus. Now, see, that's a good one. You see the CO3 2 minus, that's a polyatomic. But look at what you have. That's a 2 plus and a 2 minus. That works out perfect. So that's just MnCO3, no big deal. But what if I give you Sr2 plus and an OH1 minus? That's a 1 minus, sorry everyone. So if you put those together, so I'm just going to write them here, SROH, which one do you need 2 of to make this all work? You need 2 of the OH. So don't just put a 2 there. The polyatomic has to have brackets, and then you put the number. Let's do one more for good measure, and then I'll let you practice this one. And yes, practice, practice, practice. Let's do Cu2 plus PO4 3 minus. The PO4 is phosphate. That's a polyatomic. Now you know this. How do you balance out 2 and 3? Well, that's kind of like the lowest common denominator example from a lesson ago. Essentially what you're going to have, everyone, if I just kind of, we'll do it down here at the bottom, CuPO4. So you would have to have 3 coppers, and you'd have to have 2 phosphates. But remember, the phosphate is a polyatomic. Bracket, bracket, put the 2. There you go. Okay, everyone, I need to emphasize how important this is. This needs to be figured out. Practice. If you don't get it, ask a teacher, reach out. We've got to get this solved before we move on.